All right. Good morning, everybody. We're just having a good time this morning. It is Tuesday and it is time for learning, right? Time for learning. Time for us to get our learn on. So let me go ahead and get things secure over here. And then we're going to start. Hold on 1 second, y'all. Hold on 1 second. Writing. Okay. So what I'm over here doing, I'm multitasking. I am preparing my notes for our session for today. Well, actually, they're already prepared, but I'm actually putting them on the YouTube street. So that's what I'm doing now. And let's see if you guys can see that. No, you can't see it just yet. So here's what I want you all to do. As you're coming in, we've got to get the engagement up, guys. Y'all know it. For those of you all that I am new to, welcome to this wonderful live. I'm here today to give you guys one of the best experiences ever, okay? When it comes to learning chemistry, that's what I do. I'm not new to this. I am true to this, okay? I love teaching chemistry because I know so many students find it intimidating, but this is where I come in and pull up from the rear. I hope you guys actually feel confident in knowing that you all can get this too. Okay. So here's the thing. In order for me to give you all the best that I got to give, I need you all to tap the screen as you guys are coming in, because what that does, of course, it alerts, like I say all the time, it's like a bird call, Professor TK the chemist is in the building. We are going live right now. You all need to know all this stuff that she's teaching. That's what it does. The engagement. Hopefully this appears on your FYP page to let everyone know that this is what we're doing today, okay? That's the purpose in this live, is to let everyone know that Professor TK the chemist is in the building giving out great tutoring lessons for those of you all that may not be feeling confident in your chemistry classes. I know that so many students want to do well in chemistry, but for some reason, they just got that professor that's just on another level, okay? I would play Scrappy, get on my level, but because I'm streaming also on YouTube, they will flag this video, okay? And we don't want that to happen. But what I am wanting you all to do this morning is to get your learn on with me, because we've got so much to accomplish today, okay? We've got so much to accomplish today. And here's what I want you all to do. I want you guys to make sure that you got your pens and papers ready, because we're going to get into writing chemical formulas so that when you go to class this week, or when you go to your test and you take your chemistry test on this subject, you're going to be like, you know what? I know how to do this because Professor TK the chemist showed me some easier ways to do this, okay? So in order for us to get this engagement going, we got to run those hearts up. We've got to engage in the comments. I want you guys to engage with me as we are doing these examples here, okay? I want you guys to make sure that you're engaging in the comments. Say your answers. If you are wrong, it is okay. You know why it's okay? Because I'm here to help you get it right, okay? I'm not going to condone you unless you want some other stuff, where you want to talk sideways to my other, day ones in here, then we got some problems, okay? So that's the purpose in what we do each and every week, is to ensure everyone to feel confident in chemistry. Okay. So now, if you all are ready to engage in this comment, let's get going. For yesterday, or we started our lesson on this, we talked about how to write chemical formulas. And what we discovered is writing chemical formulas isn't hard unless you overthink it. Okay, unless you overthink it. One of the things that we started with first was just understanding the basics of the periodic table. When we look at the periodic table, we know that there are groups of elements, and those elements have charges. Those charges tell you what you're going to do. The other thing we discussed was whether or not an element was a metal or a non-metal. Because if you have a metal and a non-metal coming together, what you're going to get is a happy situation. you get an ionic compound. So I'm going to give you all a visual. I don't know if you can really see it from the screen, but hopefully you can. I've got a black pen and a pink pen. They are opposites of each other. They're not the same color. They're opposites. This would be classified as an ionic compound. They're going to swap charges with each other. Pink going to take the black's charge. Black is going to take the pink's charge. And here they are forming an ionic compound. However, if I have two black pens that are the same, all right, this would be called a covalent compound because they are the same thing. They do not swap charges. Instead, they are using numerical prefixes in their name. So when we say carbon monoxide, carbon dioxide, carbon tetrafluoride, carbon tetrachloride, dinitrogen monoxide, those are using numerical prefixes in the name because they did not swap charges, but you're telling me how many of each individual element you have, okay? That's the goal with covalent compounds. When you have ionic, they're swapping charges. They're taking each other's charges, and then you call the name like you see it. The third thing we talked about dealt with transition metals that have more than one charge. So if I have more than one charge, I've got to put that in Roman numerals. So like iron 3 chloride, iron 2 chloride as an example, copper 1 oxide, copper 2 oxide. The formulas may look similar, but they're not the same, okay? They're not the same. So as you guys are listening to these notes, I want you all to keep all that in mind as you all come through, because here's what's going to happen. And thank you guys so much for sharing the live out and for hearting it up, okay? Our goal is to get at least 10,000 hearts per live. That's minimum, okay? That is minimum, 10,000 hearts minimally. Because again, like I said before, if you all love what I'm doing, you got to share this with other people. And the way you can share, if you have other friends, you can share it to them by clicking that button in the lower right-hand corner of your screen, or you can run the hearts up so that TikTok knows we are engaging in content, okay? That we are engaging in content. Now, what we're going to get into today deals with polyatomic ions. Now, when you think about the word poly, that means two, well, actually, three or more things coming together, okay? When something is poly, think about those polyamorous relationships, okay? That's just too many people doing too many things, in my opinion. However, when you're in a polyamorous situation, that means you've got three or more things going on. So take this pen. You got a green one. You've got a pink one. You've got a black one. That's three different situations going on, right? Well, if you got three different things going on, that means the ending is going to change. We're going to have a different last name. Previously, in the other examples that we talked about yesterday and the review that I just gave you all a second ago, we talked about the ending of IDE, calcium chloride, carbon monoxide. Notice the endings were IDE, IDE. But when we talk about polyatomic ions, their ending is completely different, with the exception of hydroxides. The ending is either an ITE ending or an ATE ending. So like aluminum sulfate, aluminum sulfite. Now, there is a thing like calcium hydroxide, but again, there are only a few exceptions to the rule, but for the most part, 99% of your formulas that are polyatomic ions like this are going to be having an ending of ITE or ATE, okay? Now, what I'm going to do as we share these notes with you, you all can actually take copies of these notes and screenshot them, whatever you want to do. But if you want to get the actual copies, I have a membership that you guys can actually go for $19 a month, very inexpensively. And it has all these videos that I do on my lives. Now, while I do go live on YouTube also, Those aren't edited. I mean, it's like it's in raw form. It's raw footage. However, if you don't want to hear all this extra talking during the videos and knowing when to fast forward, I actually condense the videos down to where you just get straight to do the problem, okay, along with me. And I have worksheets. I give you over basically 100 problems per week. And it's up to you if you want to do them all, but you actually get all of this and more. You get practice quizzes. Yeah, I give you so much stuff. And $19 a month, I mean, shoot, you can drink that up in coffee 3 times. Okay? So I say all that to say, a lot of this stuff you can't get just by being on the phone. You've got to sometimes go a little deeper and have the notes that you can write out. You may have these notes in your chemistry class. Excuse me. And that's good. Use what you've got, okay? Either or, use what you've got. So notice on the screen right here, let's go ahead and get into these notes. You will see that there are some common polyatomic ions. You've got ammonium. Here's what I want you guys to know about these polyatomic ions. You've got to keep them together. Together, that means you don't split them up, okay? You don't split them up. So you'll notice that you've got ammonium, NH4, with the +1 charge. Nitrate, okay? Excuse me. It has a -1 charge. Hydroxide, -1 charge. Sulfate, -2 charge. Carbonate, -2 charge. In other words, these polyatomic ions have charges just like individual elements do, okay? They all have charges just like individual elements do. So I'm going to show you all how to actually use this to your ability. So right here on the screen, for instance, okay? If I give you, like in this first example, you've got calcium with the +2 charge, right? And then you've got nitrate. I always put my polyatomic ions in parentheses because whatever charge it picks up, that charge is going to go on the outside of that parentheses. I'm going to say that again. Whatever charge a polyatomic ion picks up, it goes on the outside of that parentheses. You cannot change the number that you see at the bottom, but instead the new number goes on the outside, okay? So here's an example. Calcium is going to pick up the 1 from nitrate, okay? So we're going to write Ca, but we don't have to write the 1 because the 1 is understood. Just like in math, when you say x equals 7, you don't have to say 1x equals 7. You just say x equals 7. Now, this nitrate compound here, the polyatomic ion, that 2 that it's going to grab goes on the outside. So I'm going to write NO3, and on the outside of that, I'm going to write that 2 right there, okay? On the outside of that, I'm going to write the 2. Now, FYI, you can never, ever change the 3 and put the 2 there in its place. You can never do that. Polyatomic ions are like your Siamese twins. If they are stuck together, you cannot separate them, okay? Because it might be a health risk, okay, to do that. So in other words, when you're writing out chemical formulas and they're polyatomic ions, you never change up the polyatomic ion and rewrite the numbers out. Instead, the new number goes on the outside, okay? It goes on the outside. Now, here's what we're going to do. We're going to practice. We're going to take our time. If you have any questions, you know what I want you to do? I want you to let me know in the comment box, hey, run that back. Hey, I don't get it. Hey, I need you to explain that again, okay? That's all you have to do if you are ever lost and need to be found. Okay, so right here, let me move myself out the way again because I'm blocking some of these notes here. But what you're going to also see, okay, are rules on how to write these polyatomic ions, okay? These rules on how to write these polyatomic ions. Again, y'all, there's nothing to it but to do it. Nothing to it but to do it, all right? So in this first part, when you are writing polyatomic ions, you want to identify the charge on each. You're going to use a crisscross method that we've talked about and use parentheses around the polyatomic ions if more than one is needed. So let me again do this next example here. You've got aluminum, which has a +3 charge. Again, the way we find these charges is on our periodic table. We've got sulfate, which has a charge of -2. There's also this thing called sulfite, okay? So for chemistry students, you've got to memorize these charges and their names. Sulfate is SO4 with a -2 charge, but sulfite is SO3, okay? So there's SO4 versus SO3. But I have these also on a chart. If you all need access to that, you can get that. So aluminum is going to take the 2, yes. So we're going to write Al2 as a subscript. Sulfate is going to take the 3. Again, you cannot write SO4 and say, well, let me just replace the 4 and put a 3. Well, where is the 4 going to go? So you cannot do that, okay? This is what you cannot do. So instead, we're going to put SO4 in parentheses, and on the outside, you're going to put a 3 right there. Okay, if you are feeling what we're saying, if you are following what we're saying, give me 10 hearts. Just tap your finger 10 times. Like, yes, Professor TK the Chemist. Yes, Professor TK the Chemist. I get what you're saying. Just tap it up. You don't have to say a word. You can just tap with your finger. That lets me know this is resonating with you, okay? That's right. Thank you, She Means Business. That's right. It is that simple. It is that simple. Yes, yes, yes. Yes. All right. Now, I've given you all some examples, right, about this. So let's go ahead and get into writing out these formulas, okay? So what I'm going to do, I'm going to go ahead and scoot this down right here. I'm going to, now, I know you all don't know the names of these compounds, and that's okay. I'm going to provide them for you because I know you don't know what they are, okay? So I'm going to provide them for you as we practice. Now, remember, your teachers will give these to you, okay? Your chemistry teachers will give you these charts so that you will already have access to them, all right? However, you need to know how to use your periodic table to identify them, all right? You still need to know how to use your periodic table in order to identify them. All right, so let's go ahead and write these chemical formulas right here, okay? You've got potassium. And I'm going to draw a line down the middle so that way you all can see this, okay? This is number 5. So potassium has a +1 charge. Sulfate is SO4, and it has a charge of -2. All right, so what are we going to do? We're going to swap those charges. So potassium is going to take the 2, and you're going to end up with K subscript of 2. Sulfate is going to take the 1, but guess what? The parentheses falls off because it's picking up a charge of 1, and the 1 is understood. So you do not need the parentheses. So this becomes your formula right here. K2SO4. K2SO4. Okay. Now, let me give you another one, okay? Let me give you another one. Trying to find, I got it on this worksheet, but we'll pick up something else. Give me 1 second, y'all. Let's see. Okay, here we go. Magnesium hydroxide. That's the next one. Whoops. Magnesium hydroxide, okay? magnesium hydroxide. Let's see what we can do with this one. Now, again, this is number 6 right here. This is number 6. I'm going to draw a line down the middle. I always do this because you're separating them so that you can keep track of what you've got, okay? Magnesium is Mg, and then with a +2 charge. Hydroxide is OH, and hydroxide has a -1 charge. You already know what's going to happen, right? Mg is going to take the 1, so that's Mg, but the 1 is understood, so I don't have to write that in. But the OH is going to take the 2. And we're going to put OH in parentheses, and on the outside is the 2. And there is your formula for magnesium hydroxide. All right, magnesium hydroxide. Okay. Hey, DJ, thank you so much. I appreciate the fact that you are, and you're reviewing. Yes, you are welcome. DJ Spooky Ari, I like that name. Okay, yes. I am glad that this is happening for you. And listen, if you need any more tricks and tips, or tips and tricks, let me know. Come on back. I'm here Monday through Thursday at 10 a.m. Eastern Standard Time. All right, now let's do another one. Okay, we've got copper to nitrate. Copper to nitrate. Again, thank you. I appreciate you. All right. So with this next example right here, we're going to draw a line again down the middle, and we're going to separate them. Again, this is one of those elements, copper, that has more than one charge. But guess what? We're going to tell you what that charge is. Because I said Roman numerals, this tells me that this element has more than one, but you are going to identify what that is. So copper has a +2 charge, because I told you Roman numeral. And then nitrate is NO3 with a -1 charge, okay? NO3 with a -1 charge. So guess what we're going to do? Swap those charges, okay? Copper said, yo, let me hold that 1. So nitrate said, all right, bet, take my 1. And then nitrate says, all right, well, since you took my 1, let me get your 2. And copper said, all right, bet, take my 2. But you got to put it in parentheses, the formula of NO3. And on the outside is that 2. And here we are with the formula for copper to nitrate. Copper to nitrate. Now, here's how you know to say Roman numeral 2. Because in the event that I give you a formula like this, where I say, all right, well, CuNO3, how do you know the name of this formula? By looking at it this way. You have to know and memorize and put in your memory the elements. Okay, good question. Cherise says, but Professor, how do we know copper has a 2 charge? Good question, love. Good question. Let me go ahead and pull up my periodic table for you right now so you will know. Good question. Good question. And listen, when I tell you guys, there's no stupid question. I love when you guys ask questions that you think you might be ashamed to ask. No, don't be ashamed. Speak out. So here on our periodic table, I'm going to scroll down and I'm going to show this to you. Oh, and by the way, right here, you see this part that's highlighted in yellow in the middle? This is the section right here that I talked about yesterday. Some of the elements have more than one charge, and students tend to make note cards with all this on there. But right here, you've got several of these that have more than one charge. These are the common ones. You've got copper, which has a +1 or a +2 charge. You've got lead with a +2 or a +4 charge. And you've got tin, element 10, SN, which has a +2 or +4. Okay? Yes, Daniela, yes. Now, You're welcome, Maddie. All right. So now what you've got to do is you see here, iron also has more than one charge, +2 or +3. So we can look at our periodic table right here. Okay. And these are the elements that I was telling them about yesterday. We actually color coded this chart. As you can see, it's a lot of colors on here. So let me explain to you what these colors represent. Okay. So right here, and I'm going to highlight them for you so you can see this. The elements that you see right here, I'm going to highlight them in yellow. Iron has more than one charge. Copper has more than one charge. Okay. Tin has more than one charge. I'm highlighting them in yellow. Lead has more than one charge. Okay. Hey, Kristen. Yes, I'm actually on YouTube right now, and these are recorded. Yes. Yes, in its raw form. Good question. I do put snippets of this on TikTok so that you guys can kind of see some of the questions themselves. But I do have this video going right now on YouTube, so I'm live on YouTube as well. But I put the edited versions of these videos in my membership so that you don't have to hear all these extra, uh, extra comments and extra questions. Yes. Yes. All right. So now, also on this chart right here, okay, what you see, these elements that have more than one charge, copper has more than one charge, iron has more than one charge, mercury also has more than one charge right here. So everything that you guys see me highlighting in yellow has more than one charge. Gold also has more than one charge. Where's AU at? AU. AU. Right next door to Mercury. Okay. Oh yeah, Triggered Mother. You're welcome, Kristen. Triggered Mother said, I'm taking inorganic chemistry. And I miss the days when I first learned about cations and anions. You know what, honey? I still got my notes from inorganic chemistry. I understand it now, but back then it didn't make sense. See, all this stuff right here comes full circle when you get into uh I'm looking right at the word, not coordinated. Yeah, coordination, numbers, and oh my, I had a brain fart, but yes, yes, all this makes sense when you get into the higher levels of chemistry. Yes. Chromium is another element that has more than one charge. Chromium, okay? Cobalt. So that's why we always tend to skip groups 3 through 12 because all these with more than one charge have issues, okay? They don't call them transition metals for a reason. Think about the word transition. It means to change. So if I'm transitioning, that means I'm changing. So that means I have more than one thing going on. Trigger Mother says, I feel like chemistry is one of those subjects that everything makes sense a year after you learn it. Yes, yes, yes. Yes, yes, yes. Okay. All right. So Sharice, I'm sure that answered your question. Got you. Thank you all so much for your questions. I appreciate your engagement. That engagement means a lot. It means a lot. Now, y'all know we got more examples, right? With these polyatomic ions. We've got more examples. And these are all examples that you see what we did yesterday. So now let's get back into some of these other examples right here. And let me find oh, here we go. Iron 2 sulfates. Yes, iron 2, whoops. Iron 2 sulfates. You have a lecture exam tonight, Sharice? Is it on this very same topic? Okay, Nanash, let's see. You said, what is the least or most reactivity? Okay, your exam is on Thursday. What do you mean? Are you asking me which element is considered the most or least active, reactive? Is that what you're asking? Okay, so right here, Iron 2 sulfate. Okay, reactivity, yes. I actually have some videos on reactivity, the reactivity series, but for the most part, as you go from left to right, it becomes less and less reactive in terms of the trends of the periodic table. As you go down a group, excuse me, they become very reactive. So you want to learn those trends and tricks and tips, especially when you get into the lab portion, because you have to do lab experiments to show which elements are reactive versus those that are not. Here is your next example. You've got iron 2 sulfate. What does that Roman numeral tell? You're welcome. What does that Roman numeral tell you? It tells you the charge. So in this case, iron has a +2 charge. Now remember, I showed you a second ago, iron can have more than one charge, but in this case, we're using the one that has a +2, okay? Sulfate, SO4, that charge is -2. Now, here is the deal with this next one. Whenever the numbers are the same, positive and negative, the same number, they cancel each other out. And when they cancel each other out, we're just left with the formula itself, and that is FeSO4. And you know what? The parentheses dropped off. The parentheses went away because it didn't pick up a number greater than 1. So in this case, we're just left with FeSO4. FeSO4. All right, y'all, let's engage. So here's what I want y'all to do while I take my break and drink my green juice, okay? I need you guys to run these hearts up for me. Do me that favor so we can engage with each other, because you know engagement means a lot on these TT streets, okay? Engagement means a lot on these TT streets. Engagement means a lot on these TT streets, okay? Run those hearts up for me. If you can get, you know what, 7 is my lucky number. I love the number 7. 7,000. I mean, that's not asking a lot, y'all. Just tap while I drink my green juice, okay? Just tap for me. Just tap. Plus, I need to parch my thirst, okay? Okay. Y'all ready for the next one? All right, we almost at the 7,000. So while you guys are clicking, let me find the next problem that we can do. All right, DJ Spooky already said, yes, we are ready. Okay, here we go. Oh, this is a good one right here. Ammonium carbonate. Ammonium carbonate. Okay. Ammonium carbonate. Ammonium. That stuff, because there's ammonia and ammonium. Nash, you said AG silver? No. Why you say AG with a question mark? Ammonium is NH4, and it happens to be a polyatomic ion. You said, I don't even know. That's all right. You engaging. That's what we need. You're engaging. That's what we need. Okay. Carbonate. Like that stuff that's found in soda pop, or I know my Detroitians, what up though? I know Detroit, y'all say pop. I think, Midwest, y'all say pop. Chi-town, y'all say pop. Down south, we say soda. Okay. Carbonate, that's CO3, but it has a charge of -2. Now, carbonate is CO3, okay? But then guess what? There's also this thing called hydrogen carbonate, okay? But this is not the one we're talking about. We're just talking about carbonate, all right? Carbonate. And now, you already know what to do. Hey, Meredith. B said pop sounds more gangster. Yeah, let me get a pop. Yeah. Yeah. Cherie says HCO3 is bicarbonate. Well, it depends on when you write it out that way. But yes, to us, yes, yes. We say hydrogen carbonate really for HCO3, hydrogen carbonate for that one. It becomes bicarbonate when you add another hydrogen to it, if you're adding hydrogen with it. Hydrogen with carbonate, with hydrogen carbonate, then you get the word bi. Yes. So with this next part, NH4 says, all right, you know what to do. We're going to swap our charges out. Okay. So NH4 says, all right, let me get that too. Let me hold something. Let me hold that too. So NH4 goes in parentheses and says, all right, I got your two. Carbonate says, well, you holding my two. Let me get your one. So carbonate says, all right, I got your one. But guess what? We do not need to put this in parentheses, the CO3 part, because the charge is one. One means it's understood. So no parentheses necessary. That's right, Kiki. NH4, 2, subscript 2, CO3. This is your formula right here. Now, oh, good question, DJ Spooky Ari. I like saying your name. Good question. Good question. Why don't the negative join the NH4? It's just the two? Yes. So when you're writing chemical formulas, you never bring the positive or negative charge in the formula writing. You only bring the number, okay? The only way that plays a role, the positive and negative charges, is when we get into oxidation numbers. And oxidation numbers is further down the road this semester. But I'm glad you asked that question. So the positive and negative charges aren't written in the formula. Okay, they only are needed when we talk about oxidation numbers. Oh, Jenna, honey, I do not teach or get it, but I got some folks that I do know that do it. Yes. Okay. DJ Spooky Ari said, I'm feeling a lot more confident. Excellent. You're welcome. I know you got to go to class. Okay. I will see you later, alligator. Take care. All right. Now, right angle says, how can I tell the difference between identifying RAT and ITE at the end of the word? Okay, now Nash, I'll see you tomorrow. No, I won't be here tomorrow, but I'll be here tomorrow night because I'm not going to be able to go live tomorrow morning. I'm out in those STEM streets doing my experiments with children, so I won't be able to do the morning session with you guys tomorrow morning, but I will come on at night because I'm not on in the morning. Yes, tomorrow night it'll be between 7 and 8. Either 7 p.m. Eastern Standard Time or 8 p.m. But I will put up a note whatever time it is. Yes. All right. Take care. Take care. The difference, I'm glad you asked that. Matter of fact, let me do one for you. Let me pull up a chart because that's going to help explain this for you. Okay. So let me go ahead and pull up my chart. And then that way you're able to see what all this means when it comes to writing out. Let's see. Trends of the periodic table. I think this is the one. Let me make sure. Oh, yes. Okay. Let me go ahead and swap my screen so y'all can see this. Okay. Lucia, I've already covered unit conversions. The unit conversions was covered way back a minute ago. Yes. I covered that like a month ago, but I do have videos on my page that you can always go and see. I do have videos on my page that you can go see. I don't do organic, Lexi. I don't teach organic. Um, equilibrium, I'm going to have a separate day for my General Chem 2 students. Because I know you all have been coming in asking me, and I'm going to have to do a day for y'all. But will you come? That's the question. Will you come? Okay, will you come? Okay, so right here, so on this chart, for those of you all that are seeing this, okay, this is the polyatomic chart right here. This is also the chart that has elements that have more than one charge, FYI. Okay, take care. I'll see you too. Maxilla, Maxilla. Oh, good, Bo. I'm glad this is helping you. Good. So I know you all had questions about the ATE and ITE ending. So let me just pull up this one chart for you right here. This is the polyatomic chart, okay? You see this? This is the polyatomic chart. On this chart, you will notice here, you see there's nitrate, right? Nitrate, ATE, nitrite, ITE, nitrate, nitrite. Oh, and FYI, to the young lady that asked me about these charges right here, here it is right here, so you all can see that, okay? You were right about the carbonate. Sometimes the name is written different. So you had asked me about bicarbonate, and I said yes. It can also be called hydrogen carbonate. So that's one of those things in chemistry where it's like, oh gosh, why do they have these names that you can't? They're not consistent. Excuse me, they're not consistent. So yes, you were correct, love. Whoever brought this up, I have to go back through the comments, but you were correct. Bicarbonate, HCO3, is also the same thing as hydrogen carbonate. See the different names? I know it's confusing. Chemistry can do that to you from time to time. But now, back over here though. Yeah, thank you, Cherise. Cherise. Thank you. I appreciate you for bringing that up. Yes, thank you. I stand corrected. And I know all these things, it be so many formulas in my head, just be going and going and going and going. But thank you for bringing that up. But if you all notice here with the nitrogen, okay, or the oxygen rather, you see how one says NO3 oxygens that have the ATE ending, and then you've got NO2 that has two oxygens that has the ITE ending. Normally, the higher the number in the group or the pair, it gets the ATE ending. Yes, Myra, that is correct. Yes. It'll be bicarbonate or hydrogen bicarbonate. Yes. So when you look at those oxygens, the higher the number in the pair gets that charge, okay, or that ATE ending. So sulfate has 4 oxygens, so it's going to get the ATE ending. Sulfite gets the ITE ending because it only has 3. But you have to look in that group because look, I don't want you all thinking that 3 here for ATE means, well, why is there a 3 there, but it has an ITE? No. It's based on what's in the pair. So if there's only 2 in that category, the higher the number, ATE. Lower the number, ITE. Okay? And then when you look at chlorate, yep, so rate is going to give you the higher. That's right. That is correct. And y'all, it gets even more interesting when you get to the chlorates, because there's chlorate, perchlorate, fluorite, hypochlorous. You're welcome, right, Angel, you're welcome. Appreciate you. Yes, the higher the number, the ATE. But again, like I said before, when you get to the perchlorates, matter of fact, I'm gonna write it down so y'all can see this. Yes, for the acid. Thank you. Cherise, do you teach chemistry? Do you? Well, let a sister know. So right here, I'm just going to write these names for you. Hypochlorites. Okay, you're learning this now. Good, 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 good. ClO. And then you've got chlorites. And guess what that is? That's ClO2. Then you've got chlorate. Now the name is changing. Chlorate. That's ClO3. And then there's perchlorate. And that's ClO4. Okay. So as you all can see right here, with all these, particularly with this section right here, y'all, it gets a little like, woo, interesting. So I would write these on index cards, okay? Excuse me. I would write these on index cards. Hypochlorite, chlorite, chlorate, perchlorate. Yes, I like that. 8 more oxygen. That's right. Yeah, I've heard those phrases too. Thank you to my look. Do you all see OMG Spessa? How could I not see you? That's one of my loyal subscribers right there. She subscribed um to my TT subscriber program. And then I also have other chemistry gems in here that are part of my membership program. I don't know if they want me to call them out. Okay. Yes, but I have other chemistry gems in here as well that are part of my membership program, and they get to get copies of all these handouts and worksheets that I do every day. I give out over 100 problems a week, okay, in the portal. Okay, that's the difference. Now, let's go ahead and see if we can do some more practice problems, okay? So that way we will know if you guys are good to go. And here's something else too. These are some key notes that you all can screenshot that'll help you remember this. IDE is for monatomic anions, okay? ATE is for polyatomic ions. ITE also, okay? Okay, no problem, no problem, no problem, no problem. Yeah, and y'all, and when I tell you there's a lot of stuff in my portal, it's only $19. And I know $19 may be a lot for some, but the $19 is well worth the investment when you get access to all of these worksheets. All of these worksheets. Okay? So let's go ahead and now move to the next part. We were talking about this problem here, y'all. Okay? And let's see. Yes, they do. These keynotes help out a lot. Yes, for sure, for sure. Yes. So you know what I'm going to give y'all are some practice problems, okay? Where you have to write the names themselves. Or matter of fact, okay, yeah. I had some other practice examples that I wanted to give y'all. But see, I would have to put the chart up and to split the screen would take a lot to do that. Let me give y'all something different. Hold on, y'all. Give me 1 second. Oh, I know where they are. Hold on. All right. Yeah, whoops. Okay, let's see here. Maybe it's behind. Oh, it's behind this one. Hold on, y'all. I'm learning all these different little things on here. Yeah, give me a second. Yeah, there we go. Okay. I've got some multiple choice problems for you all to do. And here they are. Okay. Okay, y'all. On this first one, hey Kiki, we're gonna actually get into, matter of fact, you must be looking at my notes. Real talk. I got them right here so you can see this. We're gonna do molecular formulas tomorrow. Now I know you can't see my, yeah, because I got a green screen so you can't see it. But we're doing molecular geometry tomorrow. So that's what you're talking about, the Lewis dot structures. That is tomorrow. I'll be doing that tomorrow night and Thursday morning during the live here. So yes, I'll be doing this tomorrow. Yes. Thank you so much for asking about that. Yes. Okay. So for this first problem, sodium nitrate. Okay, sounds good. Sounds good. For this problem right here, what I want you all to do, I'm going to write over here to give you an example, okay? I'm just going to give you some little things that you could possibly use. Sodium with a +1, NO3, -1, NO2, -1. All right, I gave you three things that you may need. Three things you may need. I want you to figure out of these three things here that I'm going to highlight for you in green. If this was a chart that you were looking at, I'm giving you the charge for sodium. I'm giving you the charge for two of these other ones. One of them is nitrate and the other one is nitrite. Hint, hint, hint. Which one of these formulas is going to be the correct formula? All right. So, okay. Well, we know it's not NO2 because we just talked about the ATE has a higher number of oxygens. So we scrabbed out NO2. So we know that's not the one. Good. Okay. So I see several of you all put A in the comments. You are correct. You are correct. Why? Because look, sodium has a +1 charge. Nitrate, the polyatomic ion of nitrate, has a -1. Well, those parentheses are going to drop and the ones are going to cancel out. So that's why you've got NaNO3. So yes, you are correct. Letter A is correct. Now, I don't even have to give you the hint for number 42 as this next example, other than to tell you that potassium has a +1 charge. Now, let me ask you all this. What do you think the polyatomic ion is for sulfate? Do you think it's SO4 or SO3? SO4 or SO3 for sulfate? Good job, y'all. Y'all are on it. Sulfate is SO4. All right, now here's the other thing. I'm helping you out that much. The charge of SO4 is -2, FYI. Now, since I gave that to you, let it do what it do. Write the formula out. Let me see you all write the formula out. Hey, you can book a private session with me. There is in my profile, there is a thing that'll take you straight to my website. Yes. And then you can get all of what you need. And I give you the recordings of our video, of our tutorials, tutoring sessions. I'm glad you came across too. Yes. Yes, yes, yes. And tell a friend, tell a friend. Okay. So you can save some coins as well. Thank you. Look, I'm trying to do God's work, honey. I'm trying. I am trying. Oh, yes. Look, DM me, okay? Because if anybody comes from your class, I want to make sure that you get the credit for that, okay? So you DM me, okay? Because look, if you all, and I meant to tell y'all this too, if y'all have friends, if you're in a class and it's several of y'all and y'all are having a study session, y'all can book me and save on that, okay? Because you're doing it together and y'all are on the same topic, there's no sense in y'all paying my normal fee. Y'all can book me and get the group rate for all of y'all doing this together. Oh, you at Morgan State. Go ahead, girl. Go ahead. Morgan State. Aren't y'all the Bears? Or is that Coppin State? Up in Bmore, Baltimore. That's right. That's right. No, 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 you're fine. Listen, I'm an Aggie. Okay. When I see my HBCU students coming here, I gotta give y'all credit. HBCUs in the house. Okay. Yes. And I have family in B more. So yes. Yes. Okay. See, y'all, I'm sorry we got sidetracked. But see, this is what happens. YouTube, y'all won't get an edited version. This is what you see. This is what you hear. But when you all are in my portal, I actually chop up the video. So you all don't have to hear the extra stuff, even though it's all love. Leslie, you said the answer is B. You are correct. The answer is B. K2SO4. And how do we know? Because potassium initially had a positive 1 charge, sulfate had a negative 2 charge, and they did their job of swapping. K took the 2, and SO4 said, well, I'm just going to go in parentheses. And K said, drop those parentheses. You only got a 1. It ain't like you got more than that. So SO4 said, say less. I'm going to drop my parentheses off, and we just going to rock with K2SO4. And there you have it. Letter B. Letter B. All right. And thank y'all so much for the shares and the follows. I appreciate you all. I appreciate you guys. I really do. And you know what? I cannot say that enough. When y'all engage, y'all get more from me. When y'all engage, you get more. For real. When you engage, you get more. Okay. Calcium carbonate. Synthetic, you asked, do I do covalent bonding? Are you talking about like writing covalent bonds? Is that what you're talking about? Like, what do you mean? Because that's what we did yesterday. Yes, we did this yesterday. Matter of fact, I'm just going, no, it's not on here. Well, it might, yeah. The arrangement. You mean like, okay, be a little bit more specific so I know what you mean. Because, like, if I tell you to write out, or you mean Lewis structure? Because when you said the arrangement, that made me think you were talking about something else. I just answered that question with another student. Yeah, I'm doing that tomorrow night. Since I won't be on tomorrow morning because I'll be in the community doing some experiments for some young people because they have an early release day. So I have to fill in the gap as a special person coming in for their school. I'll be doing this tomorrow night and Thursday. I'll be back on Thursday to do Lewis structure. So yes, I'm looking forward to seeing you, honey. Come on through. Come on through. You've got calcium carbonate. I'm going to help y'all out right here. Calcium has a +2 charge. Carbonate is CO3 with a -2 charge. Okay. Uh-oh, look at it, look at it. Tomorrow night, I'll be here tomorrow night. It's either going to be 7 p.m. or 8 p.m. Eastern Standard Time. But when I go live, I will put a post that lets you know for sure. It's either 7 or 8. G, look at that again, honey. Look at it again. Vanessa said A. Who else said A? Oh, you okay? No problem. The drone said, "Oh, these comments are coming fast." Hold on, let me see if I can go back up here. Ooh. These comments went fast. The charges would cancel out. Thank you, whoever who said that. Let's see. Myra said calcium already has a -2 charge. Sunsetic said, I like the way your name sounds. Sunsetic. I don't know if I'm saying it right, but Sunsetic says the twos cancel out. Yes. So guess what, y'all? When you get the same number, don't worry about positive and negative, but the fact that they're the same number, they're going to cancel out. So yes, letter A is the correct answer. Letter A is the correct answer. Okay. Now, excuse me. Let's keep it moving. Now, we did this one earlier, but I'm going to see if y'all remember. Number 44, magnesium hydroxide. Okay. Ooh. Matter of fact, I'm going to put one like this, letter E, even though y'all already know this ain't the answer. Okay. And I'm going to explain why. Even though I'm putting it here, I'm going to explain why this is not the answer. But here you guys go. Okay. Here you guys go, right here. Okay. Magnesium on the periodic table has a +2 charge. Hydroxides has a -1 charge. Do your thing, y'all, and tell me what the answer is here. Okay. I see a couple of answers in the chat box, and we're going to see if you all are correct. I see a lot of B's. I see a lot of B's. Remind me of that Nicki Minaj song. What's in the B's in the? Hold on. Look, forget that part. But Nicki Minaj had a song, "Bees in the Trap." I think that's what she said. I don't know, but y'all are right. Bees. Yeah, bees in the trap. Thank you. Listen, we're gonna give the original Queen Bee credit for this. Okay. Lil' Kim, the first B. And the answer is letter B. Okay. Mg. And in parentheses, OH2. Here's what students do. The reason why I put letter E here, even though this is not the correct answer, some students will forget to use those parentheses, okay? So here's what happens. Students know that they're swapping charges, right? You already know that they're going to swap charges. And so what they do, I'm going to slide this over here so you all can see this. But what happens is students tend to think, okay, well, magnesium is going to pick up the 1. Yes. And then hydroxide is going to pick up the 2. And they'll think that the 2 goes on the outside. Wrong, wrong, wrong. If you put that 2 on the outside of the H, you've got to put those parentheses there. And as the old folks say, you got to be more careful. Okay. So letter B is correct. For those of you all that said letter B, you're on it. You're on it. Okay. All right. Now, it is 11:12 a.m. Eastern Standard Time. Okay. If y'all get me up to 10,000, but why do we put them, what, in parentheses? Is that what you're going to finish saying? Cherie said, don't go. Well, y'all better run them hearts up to 10,000. Okay, if you don't put the parentheses there, here's what happens. And y'all, I'm live like this with my students. My chemistry students love me, okay? They love me. If you don't put the parentheses there, remember, polyatomic ions are like Siamese twins, okay? If you separate twins when they're born, together, you can have some potential health problems. In chemistry, you can have an explosion, kaboom. We don't want that to happen. And also, too, you know how they say we are not the same? Or as Kendrick Lamar say, they not like us, they not like us. Well, listen, this formula right here is not the same as this formula right here. They are not like each other, okay? They are not like each other. Okay, they not like. I'm gonna do a song. I'm gonna do a little shindig. Okay, on this. So here's the deal right here. This one, this two right here tells me I have two oxygens and two hydrogens. The one in blue says I only have two oxygens. So you see why we say they're not like us, they're not like us. They ain't the same. They're not the same. Okay? Just like two people that have on the same outfit, the one who can stunt the best, who wears it the best, gets the most attention. Okay? You may look like y'all have on the same outfit, but somebody else may have on a different pair of shoes with it. So technically, they're not the same. Okay? I know that's a weird example. You put it in, the subscripts around the hydroxide is greater than 1. Yes, thank you. Is it Zed or Zaid? Z, thank you. Thank you. So you've got to put parentheses around the polyatomic ion that picks up a charge greater than 1. Okay? Pick up a charge greater than 1. All right. Y'all said y'all want me to go. Oh, we're almost at 10,000. Y'all keep running them hearts up. We'll stay a little longer, just a tad bit, okay? Just a tad bit. Okay. Aluminum phosphate. So here's what I'm going to do to help you guys out on this. All I'm going to do over here in this little box, I'm just going to put the charges, okay? And I'm going to let you all decide what the formula, should be, all right? Oh, whoops, my bad. This is 3. Whoops, sorry. 3. Yes, 3. I'm thinking of the other one. Yes. Hey, Cameron. Okay. When you see we got the same numbers in common, you know what we're going to do? We're going to do what? Cancel them out. Cancel them out. So these 3's go away. So no parentheses is necessary. So yes, letter A is the answer. Nia asks, where did the 4 come from? Okay, Nia, there is a chart that I have, and we have polyatomic ions on that chart. Okay, let me show it to you really quickly, okay? So that way you will know where these come from. Let me see right here. I think I can. Oh, hold on. You know what? No, let me go back. Let me see if I can pull it back up again. Not that one. Oh, yeah, it's on this one. Okay, so these trends right here, these charges, these polyatomic ions are written like this. So when you said where did the four come from, phosphate is PO4 right here. I'm circling it in green. So that's where the four comes from. Okay, Kirsten, how did you do? Bella, come on through. You can watch my YouTube videos. You can go back and binge watch my YouTube videos if you get confused, okay? And Booby, you said, how do you tell the difference between ionic bonds and covalent bonds? Oh, good, you passed. Good. You're welcome, Nia. Yeah, memorizing, yes. Uh, Writing them down on index cards is helpful, but also the higher, and I'll answer your question too on the ionic compounds versus covalents. Yes, the higher the number. Matter of fact, I said it right here so you can see it. The higher the number, the it'll get the higher the oxygen, excuse me, you end up with an ATE when it's in that group. The lower the number, you end up with an ITE when it's in that group. So if you look at nitrate and nitrate ATE is for the O3. Nitrite is ITE for the O2. The difference between covalent bonds, Booby, for your question, covalent compounds are those bonds when you let me do a visual. I have two black pens. They are the same. Non-metal plus non-metal. They do not swap charges. They instead use numerical prefixes in their name. Okay? Yes, your professor should give you all a polyatomic list like this. Yes. When you have polyatomic, scratch that. Covalent bonds, again, same thing, black pen, black pen. Same thing, man, man, woman, woman, boy, boy, girl, girl, orange, orange, apple, apple. Same thing. We don't swap charges, but we just say numerical prefixes in the name. Dinitrogen tetroxide, carbon dioxide, carbon monoxide. However, a covalent compound, black pen, covalent. Ionic compound, black pen, pink pen. Different. Boy, girl, man, woman, adult, child, left, right, top, bottom, up, down. Black pen, pink pen. They're opposites. And because they're opposites, they're going to swap charges. And when they swap charges, you have to now give the name for what you see. Aluminum chloride, sodium oxide, potassium fluoride, as an example. They're just swapping charges. Ionic bonds, one is a metal, the other one is a non-metal. That's the difference. That's the difference. Okay. Yes, you can find these charts online. Yes, that is correct. Yep. You can find these charts online also. Yes. Yes, yes, yes. All right. We got time for one more. Let's see here. Let me go ahead and switch it on back. Oh, and another thing y'all want to know too, that you need to put on your list of things to know, you need to put the elements that have more than one charge. You need to know the elements that have more than one charge. Because let me tell you, if you cannot remember those, you are going to be in a world of trouble, okay? So you want to remember those that have more than one charge. Okay? Such as number 47, this one right here. This one right here. Okay. So iron has more than one charge. How do you know? Because I'm telling you in parentheses. Okay. I'm telling you that one in parentheses. So here's what you've got. Iron has a positive 3 charge. Now we have nitrate, NO3 with a negative charge, or NO2 with a negative charge. Okay. You decide which one you're going to use. Which one of these goes together? Now, you don't even see an NO2. So if you don't see NO2 in the formula, duh, disregard that one. Disregard that one. So, which one of these goes together? Okay, Adam said A. Kiki said C. Okay, let me get my water break. You know, I got to turn the camera off when I drink my water. Okay. Charisse and G said C. My other friend over here with the little bubbles and the pink heart and the pink ribbon said, I think A. Cass said C. Well, here is the answer. Let's take a look. Fe has a +3 charge. NO3. Thank you, G. I like that. Remember the parentheses, they not like us. Booyah! That part. So you got to remember, Fe is going to take the one is understood, and nitrate says, well, I got to put me in parentheses. And there you go. Fe3, NO3 with the parentheses. Okay. Is not like FeNO3. They're not the same. That's right, Ahmed. Iron can be 2 or 3. That is correct. The one that it is, though, is the +3. That is correct. Cass, come on back through or binge watch my YouTube videos. I got a whole playlist of these and on TikTok too. So if you need help, go binge watch all my videos. And I keep them short because, you know, some folks don't have a long attention span. Okay. Well, Xanax, you got me now. So you got some more chemistry you doing. Hey, we're going to be getting into some stoichiometry. And let's see here. We're going to have to do balancing equations. That comes up next week. You're on this right now? Okay. Adam says, how do you know if this is 2 or 3? Because it tells you right here in parentheses, Roman numeral 3 means +3 charge. Roman numeral 3 means a +3 charge. Okay? Roman numeral 3 has a +3 charge. So again, remember, Fe took the 1, NO3 took the 3. So if I know I'm working with 3 and 1, guess what answers you can get rid of? You can get rid of letter D because there's a 2 there. You can get rid of letter B also because there's a 2 in that one. So between A and C, I have to know that the three that the nitrate picks up from iron goes on the outside. Oh, thank you, CEO. I don't know. Thank you. Okay. We're almost at 10,000, y'all. We're almost at 10,000. So if we get to 10, I'm going to do the last one. Copper 2 sulfate. Oh, thank you. I appreciate you, Ahmed. Thank you, thank you, thank you. Y'all make sure y'all go bring y'all friends along. Listen. If y'all want group tutoring with you and your classmates, and y'all want to pay for that as a group, y'all got to come through and let me know. And I'll give y'all a substantial discount for that, okay? Because there's a difference between one-on-one versus you and your homies, okay? You and your friends, you and your compadres, you and your girls, okay? There's a difference when you're studying with a team of people versus individually. Now, some people don't want to tell how they're getting ahead, and I understand that too. So, hey, whatever you got to do to make it work, I'll work with you as well on that. Thank y'all for running me up to 11,000. Thank you, thank you, thank you. I appreciate that. So y'all are saying do number 48. You know what? Say less. We got you on 48. Let's go ahead and get to 48. Okay. Whoops. 48. Copper 2 sulfate. Copper 2 sulfate. Again, you already know it's going to be an SO4, right? So I'm going to help you out. That Roman numeral told you +2 because copper does have a +1. And sulfate is SO4. Okay. Sulfate is SO4. With a -2. SO4 with the -2. Now, again, what do you see right here? I'm at because this is SO4 for sulfate. That's the sulfate ion. That's where the 4 comes from. So ATE, ITE means there's an oxygen somewhere in the formula for a polyatomic ion. Yes. Very good question. Okay, my bubbles. She said A. Huh. Okay. That's right. We cancel charges. That's right. We cancel charges. That's right. We cancel charges. When you got the same number and the numbers are the same, I don't care if it's positive or negative, they're going to cancel out, and therefore you're left with what's left over. When the numbers are the same, I don't care about them being positive or negative. They're going to cancel out, and so you end up with A, CuSO4. Y'all are on point today. Y'all are on point today. Y'all can't get me off of here now. And I got a meeting coming up soon. Okay. I got a meeting coming up. That's right. I'm going to pass this exam tonight. I hear you, Sharice. Claim that, claim that, claim that. Yes, you got to speak it. Speak over yourself. Y'all, speaking over yourself, I have affirmations that I give my students. And I tell them before you take an exam, speak over yourself. Speak positively over yourself. And tell yourself you can, you will, you must. I can, I will, I must pass. I know I can pass. You better play Nas song. I know I can be what I want to be. Yeah, honey, book me. If you need me for your tutor, Kinley, honey, book me. I got you. I got you. And so, look, if y'all want those affirmations, I give tips on how to change your mindset. Yes, 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 G, yes. When I say divine timing, yes, yes. You go to my profile and you click that link tree thing, yes. And it'll take you straight there. But also, I mean, I have a free ebook. And when I say it's free, y'all. I don't want no money for the ebook. But when you go there, it'll tell you what to do during the test. You got to visualize yourself, y'all, going into your exam, taking your exam. Let me see if I'm gonna see if I can pull it up real quick. But no, I am serious. When I say you got to speak over yourself, you got to speak over yourself. Because there are a lot of people out here that's going to knock you off your mark, and you have to speak positively over yourself. Let me see if I can pull it up for y'all real quick. Because I mean, I give you all strategies on what to do to how to get through the test. Because a lot of times students are nervous about taking the exam. Hold on, y'all. This TikTok saying this looks like it's inactivity. I don't know why they're saying that. But yeah, you got to speak over yourself. You got to make yourself, you got to speak positively over yourself. You got to see yourself doing the right thing. You got to see yourself passing your exams. You got to see yourself knowing that if you mess up, it's okay. It is okay. It is okay. Because listen, it won't be the first time and it won't be the last time. But yes, Adam, you got to stay optimistic. And that's one of the songs I play all the time. Optimistic. Okay. You must have been in one of my lives before to know that. Okay. But I'm trying to find my little book, y'all. Matter of fact, let me do this. But yes, I am serious. You've got to speak over yourself because nobody else is going to do it for you. Nobody else is going to do it for you. This is inside one of my portals to my membership too, but you can get this for free. Yes, I can DM me and I'll give you somebody that I know who tutors in chemistry. Yes. In organic chemistry. Yes. Um, okay, y'all. I'm pulling this up for y'all so you can see. You can see these affirmations and you can see how positively you can become. Okay, y'all. Look, it's taking me some time to be multitasking. I'm multitasking between several screens. Okay, so let me do this. Oh, my daughter calling me. Hold on, y'all. Hey, Zah, I'm on my live. Can I call you right back? Okay, thank you. Talk to you in a second. Okay. All right. Okay, y'all, hold on. Yeah, bear with me. I appreciate y'all bearing with me. And thank you for the gifts. Whoever sent me a gift, thank you, Bella. I appreciate you. Thank you, thank you, thank you. Look, let me find this for you, y'all. Hold on. Let me find it. Because listen, when I say you gotta speak over yourself, matter of fact, I'm gonna show y'all a video. I've been working on this video to show y'all how I was making bad grades in chemistry at one point back in my day. Okay. I was doing bad. And I got through it because I had a professor that had patience. He had patience. One of my professors, I couldn't stand his behind. I'm trying not to cuss, but I couldn't stand him because he was just rude for no reason. And I actually got out of his class, and I'm so glad because when I took that, it was physical chemistry. It was called P-Chem. When I took that class over, y'all, whew, you couldn't tell me nothing. I actually ended up with a B in the class the second time through. Okay. So as a professor now, I can speak on it now with confidence, but yes, sometimes it's the professor that you have. Some of the teachers that you have may not be the right one for you, but you've got to speak over yourself. My first gem that I tell students, fix your mindset. Don't say, I'll never understand chemistry. Instead, you've got to change that and say, I'm learning something new every day. Or I may not understand it yet, but I will with practice. You got to change what you say. What you think about, you bring about. Okay, that's right, period. Okay, period. What you think about, you bring about. So if you're always going in, woe is me, and like, oh man, I can't stand this class, that energy alone is going to set off those endorphins negatively in your body. So you're gonna always have that situation. Your self-esteem is crazy right now, in a good way or a bad way. What do you mean, in a good way or in a bad way? Because I want to make sure. Yeah, I want to make sure. But let me go to this other thing too. The gems number 2, mindset. Okay, good. Mindset gem number 2. Put me in, coach. I got you. Building confidence in chemistry. And how you can build it is, like I said before, repetition, positive self-talk. You are capable of mastering chemistry. Listen, a lot of y'all, this is new for a lot of y'all. And we're not asking y'all to be pros in chemistry. This ain't your major. You just need this class to get through your next area of your major. And this is just one small hurdle that you got to get through. Oh, and here are these affirmations right here. If you want this ebook, it's like 19 pages. If you want this ebook, y'all, just go to my website. Okay, and it's free. All you gotta do is give me your email address and it'll send it to you. And here are some strategies that I give to my own students. Mindset gem number 3, mastering consistency and study habits. When you know you got that class that requires a lot of time, you have to build a block of schedule. It's called the Pomodoro technique. You study for 25 minutes, take a 5-minute break, go binge watch some TikTok videos for 5 minutes, then come back to your stuff. You got to break your large topics into smaller portions. Y'all, I used to be an avid runner. Okay, now your girl done gained some pounds. And because I done gained some weight, it takes me a little longer to get motivated again. So I set my treadmill, or when I go walk, I set it for 30 minutes. 5 minutes is me getting my mind together like, damn, I don't want to do this. Then by the time I've warmed up for 5 minutes, I'm now ready to put in the other 25. Okay? You have a good day too. She means business. Love you, love you, love you. You have a good day, honey. Have an amazing day on purpose. Thank you, Erin. Thank you, Justin. Listen, I'm telling y'all the truth. I love y'all. And let me tell you, I go hard for my students because I don't want them having doubt in their capabilities. So I go hard for my students. I go hard for them to make sure they can get this. You got to plan your time. So when you get to those subjects that you're like, God dang, this is hard. Mindset number 4, overcoming fear of failure. Don't go in there and say, I already know I'm going to pass this. I'm going to fail this. See, I'm speaking positively. It's hard for me to say it in a negative way. You can't go and say, I already know I'm going to flunk this test. I already know I'm going to fail this test. If you think that, you're right. You are. What you think about, you bring about. Thank you, Sharice, honey. I'll see you too. I'll see you on the next side soon. Yes, thank you. Ahmed, you have a great day as well, honey. I'll see you as well. Yeah, and I gotta get off here soon too, y'all, because I got my meeting coming up and I gotta get prepared for my meeting. But yes, thank you, Adam. Justin, what you talking about? We're gonna get into the first lesson. You're welcome, G. So yes, y'all, yes. I'm telling you, you gotta have a different mindset. You gotta have a different mindset. Like we did electronic configuration last week or week before last. So the short-term goal may be master electronic configuration this week. The long-term goal may be master it, get 85% on your next exam. Thank you, Patrice. Thank you, thank you, thank you. You have a beautiful day as well. You have a beautiful day as well. So y'all, again, you guys got to think positively. And again, this book goes on in terms of some things you can do for your test. Saying those affirmations, visualizing yourself, breathing. Y'all, we cannot forget to breathe. We got to inhale oxygen, exhale carbon dioxide. Inhale 4 seconds, exhale 4 seconds. You got to relax, relax, relax. And you got to get your rest. I know we want to burn that midnight oil, but at some point we've got to take time to relax and eat the right stuff before you take your exam. Because nutrition is beneficial to your brain, okay? If you didn't know, it is true. You got to feed your mind not only good thoughts, but good food. So again, you've got to have these confidence boosters here. Put them on your mirror for all of your classes. Tell yourself positive things every day when you walk into your classroom. You may not like the professor, but kind of send that GPS to another mindset. Okay? Have a different mindset. Again, when you take your test, for those of you out there taking a test today, during the test, skim through it at first. Just kind of look over the questions. Start with the easier questions that I got this, I got this, I got this. Then you're going to take those more complex problems and break them down. Okay? Break them down to smaller components. And self-talk. Talk to yourself. If stress creeps in where you're getting anxiety during your test, repeat. I am capable. I am capable. I am capable. I can handle this challenge. I can handle this challenge. And then after the test, reflect and release, regardless of the results. Acknowledge that work you put in, y'all. Acknowledge that work. And you got to celebrate the wins and the losses. Celebrate, celebrate, celebrate. So yes, y'all, these are just some techniques that I give my students, whenever we are in class. I be pepping them up. I'm like, yeah, you got this. Knock it out the box. And y'all, a little funny thing. When my lipstick is gone, that means I did a good lesson. Okay. My lipstick is gone. Because I done taught a good lesson here today. And I've been on here almost 2 hours. Woo! I gotta go for real, y'all. I gotta go for real. But I will see you all. Thank you, Maya. Thank you, Lydia. Thank you, Natara621. I appreciate you guys. Don't give up on yourself. Keep pushing, keep going. Remember, you got this. Even if you're taking this for your TEAS exam, many of you guys are trying to get into the nursing program. Remember, you got this. I'm talking to you. You got this, okay? All right? Hug yourself real tight and tell yourself you love yourself and that you too will get through this, okay? Y'all have a good one, and I will see you guys tomorrow night, okay? Tomorrow night. Take care, guys.